Okay, here's a warning for you. Correlation does not equal causation. What does that mean? It means that just because two variables are strongly correlated, that there's a strong linear correlation or any type of correlation, it does not imply a cause and effect. You can't assume that X causes Y or Y causes X. So here are some questions you're going to want to ask yourself if you have a significant correlation, okay? So the first one is, actually analyze the situation. Is there a direct cause and effect relationship between the variables? Does it make sense? So what they're talking about in this example is the gross domestic product and the carbon dioxide emissions. Yeah, it kind of makes sense, right? It's reasonable to conclude that as the more manufacturing products that are made, the higher the CO2 emissions, okay? So actually take a step back and analyze the situation, okay? Look at question number 3. Is it possible that the relationship between the two variables can be caused by a third variable or perhaps a combination of other several variables? Yeah, think about outside factors, okay? There was one example over, let me scroll up, sorry, oopsie. I deleted it. Okay. Well, there was one, going back to your notes, there's a graph that talks about attendance and grades. Okay. So, some people may have lots of absences, but maybe they take care of their work at home and they study a lot at home and they still get good grades. Okay. So you really want to think about that outside factor, any third party, any third variable, combinations of those, what's happening outside. Okay. And then the last one is maybe it's a coincidence. Okay. Maybe it's a coincidence. Okay. There was that example of that graph, that one of the last graphs we talked about, where it was like if you make more money, you buy more milk. That's probably a coincidence. Okay. So you really want to analyze the situation, and you can't just assume that causation or correlation is causation.